Refactor or preserve, challenging the if it ain't broken, don't fix it mindset in Shiny App Lifecycle. My name is Dror and I'm an independent consultant. I'm going to talk about Refactor, redo from scratch, no more patching, the what, the why, the when, and how. A disclaimer, I am not a software engineer by training. I'm just an R programmer who wishes his solution lasts longer. So this would be a bottom-up approach reflecting my own experience. My background, I was trained as a statistician. Early in my career, I used SAS, then switched to S+, here a screenshot, and then R. I consider myself an early adopter of R web applications. So back in the day, before Shiny was a thing, I was playing with Apache, Brew, Rook, WebSockets, and others. I use R for many other things, genomics, biomarker discovery, clicks, IOs, and I use the terms data science, real-world evidence, epidemiology. But at the end of the day, I'm doing descriptive, visualization, inference, machine learning, and causal inference. These are places I've been studied, teaching, working, and more recently in pharma industry. So my day usually starts like that. I'm introduced to some messy data, and I've been asked to make order and derive some insights and impact out of those insights. I'm even more excited when I get to see the code behind these messy data sets. And here's, for example, a for loop with if and another nested if. So I'm sure you're all familiar with this type of spaghetti code, right? I'm actually getting excited when I see it because to me it's like detective work to figure out what's going on and make it nicer. So I get it. Nobody wakes up in the morning and says, hey, today I'm going to write a spaghetti code. But somehow it turned to be a natural step of writing code and doing software. So my tasks are usually to dive into these complicated data analytics pipelines and fix them, either adding a feature or find a leak and patch it. So if I'm lucky enough, I'm able to find it and then patch it. And I do it once, and sometimes I have to do it even 2 places. So I patch and I patch and I patch until by the end of the day, I end up with something that looks like this. Not fun at all. So imagine all I wanted to do is add one tiny feature, right? That would make my scope creep. And sometimes that scope was already about to creep. There was no doubt about it. But adding another feature beyond the initial capacity have made it to no longer be efficient and nice. I define it as scope creep. Let's look at the definition. Uncontrolled or gradual expansion of project scope. Adding features, requirements, or work beyond the original agreed upon plan, without corresponding adjustment to the resources. So let's describe how it goes in general. I'm going to add one more tiny feature. I hope nothing will break. I already know the scope is about to creep because I have spaghetti code. Oops, the scope's just creeped. Now I better understand the limitation. I learned my lessons, so no more patches. And next, I will build a better solution from scratch. Will this solution last forever? Probably not. It will keep again, and here's the life cycle of the software and the code. This is a product adoption life cycle, also known as innovation adoption curve. On the left side, we have the innovators, a solution that was invented, created in order to solve a pain point. If that solution is good, over time it will gain some popularity by early adopters, and later on, even more people, early majority and late majority. And also on the right side, we will have the laggards, users that will not use that solution because they never had the need to. Let's look at this with specific R packages as a case study. So once upon a time, R base was invented in order to solve some pain point. Then in the past, it got more popular and got more users around it, but it also had some other challenges that were not initially solved by the base version. And that's when tidyverse and shiny packages, frameworks, were introduced and gradually start to get more popularity and users. In the near present, base again, still being used, but pushed towards to the side. Tidyverse and shiny are being more popular. And a new framework called module, which is function for shiny modules, was introduced to solve some complexities of the shiny framework. At the present, base was pushed to the right, tidyverse and shiny are very known today. Module is also kind of like known. And two new frameworks were introduced, Teal and Rhino, in order to solve problems that the model system by itself could benefit from. Let's look at an example comparing base and tidyr. Here's the function expand grid, which is doing a Cartesian product or a cross join. And the original version of that in the base was about 20-25 lines of code. And in the new version, it is much more concise and expressive in just under 10 lines of code. Read more about it in a blog of mine, The Essence of Our Expand Grid Function. Another example, back in 2018, I was writing a blog about my favorite machine learning packages, which are Caret and MLR. Little did I know that only 1 year later, in 2019, each of these packages have been refactored by their creators, and Caret became tidy models, MLR free, which is a natural process of software design. What I guess was happening is that the developers of these packages figure out that the initial scope for these packages has reached its limitation, and they decided to redo it from scratch. So these are examples of refactoring is already all around us. Next, I will focus on Shiny framework, and specifically the Teal and the Rhino and Box framework. Even before Shiny was a thing, around 2005, Jeffrey Horner introduced a package called R-Apache to bridge between Apache and R. Later on, around 2010, Jeroen Ooms introduced the Brew package to handle the get, the post, the put, and look how simple was the UI. But then Shiny was introduced later on to make things even more nice. And Shiny introduced the relationship between the UI and the server to manage the input and the output the way we all familiar with it today, and also the communication with the client through the server. And it also got a lot of popularity because it suggests a very simple and perhaps intuitive structure. We have the UI, which is in charge of the layout, right? The inputs, the GUI, and the output. We have the server that take care of the logic, the computation, the processing, the reactivity. And in between, we have the reactive engine, which is in charge of the binding and the graph of the connection between the UI and server. Even though here I plot them kind of like as separate non-overlapping circles, in reality, they are overlapping and intertwined within each other, which creates sometimes some complexities. Modules, functions for Shiny apps, could come and help. The question is, where can I find modules so I don't need to write them each time from scratch? Luckily, I did find some by the Pharmaverse open source community, which developed an ecosystem called Teal. This was already a topic of my talk last year at the both ShinyConf and Cascadia R. So go check those recordings on YouTube. What I like about Teal is that it could create nice Shiny apps with nice templates and UIs with just about less than 10 lines of code. Because things are done at the module level, I would call it as high level, you could just bring in those modules to your apps without have to deal with things that happen at the lower level, like input, output, reactive, observe events. Assuming you're good and satisfied by these modules, you could play and focus on the what instead of the how at a high level. What I like about this framework is that it's not only leveraging on the module in order to solve and untangle the intertwined complex binding. It is also makes some assumptions on the data structure and the meta UI in order to untangle it and make it even more isolated and easy to control. Why I love Teal? It breaks the tangled complexity of data UI server beyond what a module could do. It's a cross-industry community effort, therefore also support. The community provides a public catalog of advanced modules, for example, MMRM, mixed modeling. In-house modules could be easily integrated into Teal. The developer could focus on the what and less on the how. And it also leverages advanced best practices tools such as validation, logs, and checks for me to learn and adapt. A common problem is, even after you were able to write a really nice, shiny app, is that it's working on your computer but not on others. And this might be due to different configurations of the server where the app is hosted. Even though we hope it to look one way, it may look this way on one server and that way on another. How do we resolve that? So here comes packages such as Box, which suggest that instead of using an implicit way of calling library ggplot2, one should use explicit using the Box syntax. Another example is the Rhino framework, and here I will focus on just one feature of that framework. There are many more, which is a recommendation for a file system to host each of the files in the app. So different files with different roles, such as test and styles and JavaScript, have their own designated slot to be used and make the maintenance of the app more easy for the developer. So together, Box and Rhino offer clear code, quality, automation, and much more. For example, unit test, E2E test with Cypress, logging, mounting, linting. These are intentionally in red because when I was introduced to this framework, I didn't know what it meant. I didn't encounter these type of challenges that these solutions were designed to solve. And then it brings me to a point of when refactoring is not necessary. It would be nice to have this groceries cart have additional features such as a wheel and engine, but this is also depends where I'm going to use it. If I'm going to drive it on a smooth surface in a grocery store where everything is handy, that might be not necessary and an overkill. If on the other hand, I'm going to use it out there in the wild, these features are definitely going to be appreciated. Let's say everybody already used Teal, Rhino, Module, Tidyverse, but we still have another new pain point. So this refers to the future. How are we going to solve that? So here's an example. My pain point was wrapping session management, bookmarks, in a module. I was trying the conventional modules, which is functional, and I had some difficulties, maybe because this is towards the end of the scope of the functional framework. I then ran into a package called Tidy Modules, which introduced an object-oriented R6 to handle UI and server via a semantic references. Under this type of design, it supports session management with flexible user sessions and cachings and others. So my current decision is whether I should trust this package to solve my pain point and adopt it or not. Because I don't know too much about this package. I don't know whether it's going to be maintained for long. I don't know if it's going to gain popularity and support. So I'm still kind of like debating myself. I was really excited about the R6 and thought, why not doing it with the S7 object-oriented? And here comes AI, which maybe brings us to a new era where instead of refactoring, we just ask AI, LLM, to refactor it for us. So I used a simple prompt, demonstrate our Shiny app with an S7 object-oriented. And I got something. And it actually did work, even though it was with R6 class. I insisted on the S7 object-oriented, and not much of success yet. So to summarize, when to refactor and when not to refactor. Do refactor when you have a deprecated dependencies, when your current scope is creeping, when the solution to a critical pain point is not supported by your current scope, and when you trust the new solution. So it's about ownership. Do not refactor if you can't replicate legacy methodology that you don't fully understand or own. When it's an overkill feature, you would still be fine without it. Don't break it for others, make no harm. And sometimes modern frameworks come with heavy burden dependencies. Risk versus ownership, no free lunch. I would definitely encourage you to be brave and just do it and try any new package out there or solution that you find interesting. Take the risk, get dirty, use AI LLM to study it. It's fun. But keep in mind that no free lunch, this comes with a cost, right? The resources may be limited, so therefore you need to be prepared to fully own it, no matter what the cost is. Which brings us to the next point. Sometimes it's beyond code. Nobody really cares about your code. What people care is whether it solved the critical pain point. Therefore, you should get your buy-in from your team, management, clients. When you're all in, it means you own every aspect of the new solution, even if you're the sole maintainer of that solution. That's not fun. Ask yourself, can I trust person X to use solution Y to deliver the job? How much is that resource going to cost me? Can I retain it? Does it worth it? Sometimes it's just external forces, right? The organization is no longer going to support proprietary software, and you will need to port it to some other languages. So I used to think my life was simple. I should just make it work, and if I should make it fast. Later on, I learned that there is a whole things in between that would make it even stronger and last longer, such as reliability, usability, evolvability, modularity, accuracy, scalability, portability, you name it. When I was introduced it, so what's in between is basically how to make it right, not just work. And here are the software design principles that I've already discussed, some of them. Agility, do not repeat yourself, keep it simple, you ain't gonna need it. When you add these type of components, you add some layers of protection to the code, which will make it last longer and less susceptible for scope creep. So even though we cannot avoid scope creep, I would argue at least do it in style, meaning add layers of protections around your code. Here at the core, we have our code, a Shiny module with functions and data. One first layer of protection is the package system, which will handle the version, the dependencies, the testing. Next, we want it to be accessible for other users, so we could wrap it in an application as Shiny app or REST API, and there are packages to do that. Next, we're going to host it in a container. And lastly, we'll add another layer of version control with Git to track changes of our code. So what is the secret sauce for a successful refactor? What I love about our open source community is that there is no secret sauce, right? These are the best practices that the community is developing and sharing with each other, such as modern frameworks, reproducibility, testing, modularity, version control, readability, documentation. And these are all come with experience. I consider myself to be on the left side of this curve as an innovator and early adopter. However, sometimes it could be risky to choose and bet on the right solution for your problems. Instead, I would say use someone who is experienced, someone who already learned from their own journey to show you the right way, someone you could trust. Thank you.
So there's a couple comments in chat about people asking about chat. So I'm going to actually focus in on this talk, and I'll start with that was a beautiful presentation. Your slides, your images are just top tier. So well played. Now to the content. You obviously are a masterful programmer. You've got experience. You're using all kinds of like intermediate to very high level tools. And I teach, and so I have students who get a copy of Master Shiny. They start to build things, and then all the things you expect go crazy. Do you have any advice to go from someone who's read the opening chapters of a shiny book to becoming a master and working with these frameworks? What are good tools to help people go from zero to hero?
Thank you for the feedback. Yeah, that's a great question. I would say focus on one pain point at a time. So get it to work with the basics. And then based on your priorities, make an effort and polish different corners of your app. If it's a big data set, figure out how to make it run faster, see where the bottlenecks in terms of data streaming. If it's some fancy visualization that you know will get your end user's attention, spend time on that. And make those changes, modification in even small incremental ways so you don't break the whole tool.
Excellent. I wish we had more time, but our next talk is going to start in 11 seconds. So I will say thank you. I greatly appreciated the presentation, the style as well as the content, and I look forward to seeing more. That was beautiful work. Thank you.
Thanks.